All right, this is lesson 5-6, parallel and perpendicular lines. We are going to learn how to determine whether lines are parallel or perpendicular in either, mostly by looking at their equations, to write equations of parallel lines and perpendicular lines. So one of the things we need to recall is what a reciprocal is. So number one says circle the product of a number and its reciprocal. When you multiply a number and its reciprocal, you always get 1. Numbers that are reciprocals are any two numbers multiplied together that equal 1. All right. And actually, 0 doesn't have a reciprocal because there's no number you can multiply by 0 to get 1. So just a little bit of vocab here. Perpendicular means two lines that cross to form a right angle. And in symbols, there is a symbol for perpendicular. Looks like this. So if I say something like this, AB, so that means segment AB is perpendicular to segment CB. And then there's another set of symbols here. You can see that a double line like that means parallel. All right, so the railroad tracks in picture A are parallel. The window bars in picture B that do not meet are, so the ones that don't meet, that'd be these. Those are parallel. And in C, picture C, the roads are perpendicular. They cross to form a right angle. All right. So here's a concept that we need to see, and you could check this out on your graphic calculator, whatever, but non-vertical lines are parallel if they have the same slope at different y-intercepts. Vertical lines are parallel if they have different x-intercepts. Draw a line from each equation in column A to the equation whose graph is parallel in column B. So in order to be parallel to y equals 2x plus 4, we need the same slope but a different y-intercept. That would be that one. And to be parallel to the equation y equals 1/3 x minus 2, we need the same slope, which is 1/3, but a different y-intercept. And for vertical lines to be parallel, we just need a different x value. So those two lines will be parallel and vertical. Writing equation of the parallel line. So it says, what is an equation in slope-intercept form of a line that passes through point 215 and is parallel to the graph of y equals 4x minus 1? Well, if it's parallel, that means it has to have the same slope. So we know the slope is 4. So we know part of the equation. We know that we're going to have 4 times x plus some y-intercept. Now, to find the y-intercept, which is different than this one, it's not -1, we have to use this point. Well, that's an x and a y value that will be on the graph of this parallel line. So if I substitute 2 for x and substitute 15 for y, add the y-intercept, I should get a true equation. So 15 has to equal a plus b. And if I subtract b from both sides, I see that b is 7. So my equation is y equals 4x. The 4 makes it parallel, and the plus 7 makes it so that it works with that point. And just to prove that again, I know that 4 times 2 plus 7 has to equal 15. And 4 times 2 is 8, and 8 plus 7 equals 15. So it checks. All right, go ahead and try it. You can pause and then check back for your answer. I'm going to go through this problem because the example I gave earlier was using slope-intercept form. This is using point-slope form. So we know that we want a slope of 2, and we want it to go through the point -3, -1. Well, using the point-slope form, we can just substitute the values into the equation. And so I'm going to subtract the y1 value, which is right there, -1, and the the slope I'm going to substitute in is 2, and the x value that I'm going to subtract is -3. And then I'm just going to simplify that. And I get that equation. All right, another concept. Slopes of perpendicular lines. Two non-vertical lines are perpendicular if the product of their slopes is -1. Two numbers whose product is -1 are called opposite reciprocals. A vertical line and a horizontal line are also perpendicular. So the slope of a line is 2. What is the slope of the line perpendicular to that line? That would be the opposite reciprocal. Well, the reciprocal of 2 is 1/2. So the opposite reciprocal would be -1/2. And just to show you that that's true, check this out on a graph. So the slope of that line is 2. You can see we go up 2 for every one we go over. Now, this line is perpendicular. It's created as such. And if you look at the points on that line, you will notice that their slope is, we're going down 1 for every 2, and down 1 means -1 for every 2 we go over, which is -1/2. So opposite reciprocals give you, slopes give you perpendicular lines. So are the graphs of 2y equals -3x plus 6 and y equals 2/3 x plus 2 parallel, perpendicular, or neither? Parallel means they would have the same slope. Perpendicular would mean they would have opposite reciprocal slopes. And anything else would be neither. So we need to find the slopes, basically. This one is written in slope-intercept form, so that equation has a slope of 2/3. So we'll say m is 2/3 there. Slope is 2/3. The other equation is written in some other form, but it wouldn't be really hard to change this to slope-intercept form. All we would have to do is isolate the y by dividing both sides by 2. We need to divide everything by 2, and we get -3/2x plus 3. And now we can see, now that it's in slope-intercept form, that slope is -3/2. And the 2/3 and 3/2 are reciprocals. And we have one as the opposite. And you could check that by multiplying. If this is true, and 3 times 2 is a negative times a positive is a negative. 3 times 2 is 6. 2 times 3 is 6. And that's -1. So we're going to say that these are perpendicular. All right? Go ahead and try this one on your own. You can check back for the answers. So we worked it out, put it in slope-intercept form. You can see my work here. Now, the question is, so one of them has a slope of 3/4, the other is 4/3. Are the lines parallel, perpendicular, or neither? So, are the slopes the same? No. 4/3 is not the same as 3/4. Are they opposite reciprocals? They are reciprocals, but they're not opposite reciprocals. So our answer is neither. All right. Graph of which equation passes through 10, 15 and is perpendicular to the graph of y equals -5, 6x minus 2. To be perpendicular, the slopes have to be opposite reciprocals. So what slope is the opposite reciprocal of -5, 6? And that would be, flip it over to get the reciprocal. This is negative, so this one needs to be positive. So opposite reciprocal would be 6/5. So just given that information, we can eliminate any equation that doesn't have 6/5. A and B. Now we just need to know the right y-intercept. And given that you have a point and you have two equations, you could check which of those points works. But just in case you don't have answers, let's let's write the equation out. Since we have a point, we know the slope is 6/5. Let's use the point slope form. And so we're going to substitute for y1, 15. We're going to substitute 6/5 for the slope, and we're going to substitute 10 for x1. So 1. And then we're just going to simplify this by using the distributive property. 6/5 times x is 6/5 x, and 6/5 times 10. You can use your calculator if you want, but 10 divided by 5 is 2 times 6 is 12. And then I'm going to add 15 to both sides, and I get y is equal to 6/5 x plus 3. So there it is, answer C. All right, a line passes through 1/8 and is perpendicular to the graph 2x plus 1. What equation represents the line of slope intercept form? I'm going to pause. You could try this. All right, Carla is using a coordinate grid to make a map of her hometown. She plots Main Street as shown, and 3rd Street is perpendicular to Main Street at 5/7. What is an equation for 3rd Street? All right, for an equation, we know that it goes through that point, so we have a point. If we had the slope, then we could write the equation in point slope form. And this line is perpendicular to Main Street, so we can find the slope of Main Street. Put a dot there, and it looks like maybe there. And so I think that my slope is going down 1 for every 5. So Main Street is the slope equals -1/5. So the slope of the other street perpendicular to that, 3rd Street, is the opposite reciprocal. So flip those over, 5/1, make it positive. So the slope would be 5. So now I'm going to use my slope intercept form. Substitute the y value, which is 7 for y. The x value is 5, and the slope is 5, and there's an equation. Go ahead and try this problem. Check back for the answers. Here's the rest of your answers. To determine if 2 lines are parallel or perpendicular, you need to check the slopes. The difference is if you are seeing if they are parallel, you want the slopes to be the same. If you're seeing if they're perpendicular, you want the slopes to be opposite reciprocals. See you tomorrow.